Good morning. Today's lab is an experimental determination of the molar volume of hydrogen gas at STP. The molar volume of a gas is the volume that 1 mole of that gas occupies under a certain set of conditions. At standard temperature and pressure, that being 0 degrees Celsius and 1 atm, the molar volume of an ideal gas is about 22.4. Hydrogen gas is the lightest of all the gases. The intermolecular forces of attraction between the molecules are fairly weak. And so, because of this, essentially, hydrogen gas behaves as an ideal gas under most laboratory conditions. We'll generate hydrogen gas through a reaction between magnesium and hydrochloric acid. Magnesium comes in a ribbon, and we'll take a small piece of it and tie it to a piece of copper wire that has been inserted into a rubber stopper that we'll use to hold the magnesium strip as it reacts with the hydrochloric acid. Then we'll take the rubber stopper and place it in the bottom of a eudiometer. The eudiometer is a piece of glassware that is often used to collect gases from a chemical reaction. The graduations on the device allow the volumes of the gases to be measured accurately. The first step in our process would be to fill the eudiometer with 3 molar hydrochloric acid, about 15 milliliters. And then we'll carefully place or dispense distilled water on top of it in such a way as to avoid mixing between hydrochloric acid and the distilled water. The next step is to invert it in a water bath with the rubber stopper inserted into the bottom of the eudiometer. What you'll notice is that the hydrochloric acid will diffuse down to the bottom. As the hydrochloric acid reacts with the magnesium strip, hydrogen gas will be produced, and since it is lighter than the water inside the eudiometer, it will rise and displace the liquid downward. At the top of the eudiometer will be the hydrogen gas. The next step is to take the eudiometer and place it into a graduated cylinder that has been filled with water. The point of this is so that we can measure the pressure inside of the eudiometer. We'll do this by raising the eudiometer so that the water level inside the eudiometer is equal to the water level inside of the graduated cylinder. Doing this equalizes the pressure inside the eudiometer to the pressure outside. We do this so that we can know accurately the pressure inside of the eudiometer. The next thing we'll do is we'll measure the temperature of the water inside the graduated cylinder. We do this for 2 reasons. For one, the temperature of the water represents the temperature of the gas inside of the eudiometer. The other reason we need to know the temperature of the water is so that we know the vapor pressure of the water that's inside the eudiometer. Even though most of the gas inside the eudiometer will be hydrogen gas, a certain portion of it will be water vapor, as the water inside the eudiometer will vaporize to some extent. Knowing the temperature of the water allows us to know the vapor pressure of the water inside of the eudiometer. From this, we can subtract the vapor pressure of the water from the overall barometric pressure inside of the eudiometer. The temperature of the water needs to be measured so that we can actually know what the vapor pressure of the water is at that particular temperature. So here's some sample data that is very similar to the data that you'll be collecting in this lab. A reaction of 0.028 grams of magnesium with excess hydrochloric acid generated 31.0 milliliters of hydrogen gas. The gas was collected by water displacement in a 22-degree water bath. The barometric pressure in the lab that day was 746.0 millimeters of mercury. From this data, calculate the molar volume of H2 at STP. So the first thing you need to realize here is that the conditions of the experiment were not at STP. 22 degrees Celsius and 746 millimeters of mercury is not the standard temperature and pressure. So what we need to do is we need to calculate what the volume of the hydrogen gas would be at STP. So to do that, we'll use the combined gas law. The initial pressure of the hydrogen gas is the dry pressure of the hydrogen gas in the eudiometer. The initial temperature is 295 degrees Kelvin. The initial volume, of course, is 31 milliliters. Again, at STP, that's the second pressure, or P2 is 760 torr and T2 is 273 Kelvin. Our task is to figure out what the volume of the gas will be at STP. So first, before we calculate the molar volume, what we need to do is to calculate the theoretical number of moles of hydrogen gas that would be produced from the reaction, and that's laid out before you. The next step we need to figure out is the dry pressure of the hydrogen gas. It's given in the problem that the barometric pressure that day was 746 millimeters of mercury, and at 22 degrees Celsius, the vapor pressure of water would be 19.8 millimeters of mercury. And this information we use reference material to calculate, to determine. What we do from these two values is we subtract the water vapor from the barometric pressure, and we arrive at a dry pressure of 726.2 millimeters of mercury, and that is our initial pressure of the hydrogen gas. Inserting into the combined gas law, we arrive at a value of 0.0275 liters, and that is the volume of the hydrogen gas at STP. The molar volume of hydrogen gas can be determined by taking the volume of hydrogen gas and dividing it by the theoretical number of moles, and we arrive at a value of 23.9 liters per mole. Of course, there is some experimental percent error associated with this value, and as always, with our value, we'll also calculate a percent error.
So as you can see, this piece of magnesium has a certain amount of oxidation on it. First thing I'm going to do is to strip off the oxidation to ensure that the piece of magnesium that I'm using does not contain the magnesium oxide coating. So as you can see, the magnesium is a lot shinier. It has the characteristic luster that you would expect from a metal. I was not able to get all of the magnesium oxide off the surface, but it should be good enough for our experiment. Okay, so at this point I'm going to measure the mass of the strip of magnesium and put that on the scale. The mass of the magnesium strip is 0.0386 grams. Okay, so this is a eudiometer. It is a piece of glassware that is used to collect gases over water. Notice that there are gradations on the device. Notice that one end is completely sealed and the other end is opened. And we will use this to collect the hydrogen gas in this experiment. And here is I've created somewhat of a cage using copper wire to, as best I could, trap the magnesium strip into this stopper so that it will allow the magnesium strip to react with hydrochloric acid. Okay, so what I've done here is I've filled my eudiometer with about 15 milliliters of 3 molar hydrochloric acid. I'm going to add distilled water to the top of this in such a way to avoid mixing the water with the hydrochloric acid.
Pick up everything that's above stuff right with. And Barbara, you think you're going off?
Okay, notice that the reaction has stopped. The magnesium strip is completely consumed. And at this point, I'm going to take the udiometer out and place into another graduated cylinder so that I can measure the volume of the hydrogen gas collected. Okay, so I've taken the udiometer out of its setup and I've placed it into a graduated cylinder filled with water. Notice that the gas is still trapped and submerged inside of the water that's inside of the graduated cylinder. I will leave inside the water for a period of time to allow the temperature of the water to equilibrate with the temperature of the gas inside of the udiometer. The temperature of the water bath is 19.5 degrees Celsius. And at this point, I'm going to measure the volume of the gas inside of the udiometer. I'm lifting the udiometer so that the level of the liquid inside the udiometer is equal to the level of the water inside the graduated cylinder. I'm doing this to ensure that the pressure inside the udiometer is equal to the atmospheric pressure outside. So I'm going to read the udiometer very carefully. It's really hard to read that. It looks to be about 32. Sorry, get that closer up.
The measurement looks to be about 31.45 milliliters. So here's all the data that you'll need to complete the lab. You have the mass of the magnesium ribbon at 0.0386 grams. The barometric pressure was 770 millimeters of mercury. The temperature of the water bath was 19.5 degrees Celsius. The vapor pressure of the water at that temperature is 17.0 millimeters of mercury. And the volume of the hydrogen gas was 31.45 milliliters.